So this is an easy question. All we need to do is times the numerator and the denominator by the same number. And we would just repeat the process, this time with a different number. So as you can see here, it's pretty self-explanatory. So our equivalent fractions are 6 over 10, 9 over 15, and 12 over 20. But you could use any number so long as you make sure that you multiply the numerator and the denominator by the same number. Okay, so question 2 is asking you to find all the equivalent fractions in this list. Now, you know how to make a fraction equivalent. A quick way to find out which of these fractions are equivalent is to simply highlight the multiples of the numerator and the denominator. So what do I mean? So you can do as follows. So for the first one, we can see that 3 times 1 is 3 and 8 times 1 is 8. So that's the first one there. Now 3 times 2 is 6 and 8 times 2 is 16. Do we see a 6 over 16 in this list? No, we don't. So you can have a quick scroll down each of these. So 9 over 24, we don't see that either. 12 over 32, we don't see that, and so on and so on. So you can just keep doing that until you find an equivalent fraction. But in this case, you won't find an equivalent fraction for this fraction here. So let's try the next one. So we've got 4 over 15. So again, 4 multiplied by 1 is 4, 15 multiplied by 1 is 15. Okay, so that's already there. Is there another fraction that's equivalent to that one? So 4 over 2 is 8, 4 multiplied by 2 is 8, 15 multiplied by 2 is 30. Again, we keep doing this until we find an equivalent fraction. And if you have a look, you'll notice that there isn't one that exists in this list here. So we can rule that one out as well. So now let's go to the next one. So we have the multiples of 1 and the multiples of 6. So we have the first one. We know that 1 multiplied by 1 is 1, 6 multiplied by 1 is 6. Okay, so what about 1 multiplied by 2? That's 2. 6 multiplied by 2, that's 12. Do we see a 2 over 12 in this list? Yes, we do. It's right there. So that's one equivalent fraction. So 12 over 2 is equivalent with 1 over 6. Is there any more? Let's have a look. So we've got 1 multiplied by 3 is 3, 6 multiplied by 3 is 18. Is there a 3 over 18 in this list? Yes, there is. It's there. And we can keep on going. 1 multiplied by 4 is 4, 6 multiplied by 4 is 24. Is there a 4 over 24 here? No. Keep going. 5 over 30. Do we see 5 over 30? Yep, there's one there. We can highlight that one. And we can keep on going, so you get the idea. So we've got 6 over 36, I don't see that. 7 over 42, I don't see that. We have 8 over 48, there it is there. So that's another equivalent fraction. And is there any more? We can keep having a look. If you do keep looking down, you'll see that there's a 14 over 84 here. So that's also equivalent. Alright, so that should be about it. So there you go. There's a quick way of finding equivalent fractions. Okay, so this question is all about simplifying down as far as we can go. We know that to do that we have to find the highest common factor. To find the highest common factor, we look at your multiplication table and we try and find the numerator and the denominator in the same row or the same column. So in this case, I can see that there's a number 15 over here, and there's a number 40 over here. So I know that the common factor is the number 5. So 15 divided by 5 is 3, and 40 divided by 5 is 8. Okay, so next one. 14 over 20. I can see that there's a number 14 over here and a number 20 here. It's in the same row of multiples, in this case the multiples of 2. So 2 is the common factor. It's the highest common factor because you won't find it anywhere else. You won't find these two numbers in the same row anywhere else. So 14 divided by 2 is 7, 20 divided by 2 is 10. So we can go ahead and write that down. So your answer should be Your answer should be 7 over 10. Okay, so let's go to the next one, 62 over 90. I'm looking for the number 62 in the same row or the same column. In this case, it's going to be a little bit hard for me to find 62 and 90 in the same row because I can't seem to find it. That is because it's actually in the multiples of 2. But the multiples of 2 only goes up to the number 25 here. So 2 times 25 is 50, and that's the highest it goes. But remember from the last videos that we've done, I'm not sure what part it was, but if the number ends in an even number, if both numbers end in an even number, then you know definitely that the number 2 will go into both numbers. So in this case, we can simply divide the numerator and the denominator by the number 2. And if you do that, the answer we'll get is 31 over 45. And you also know that you can't simplify this anymore because you won't be able to find the numerator and the denominator in the same row. So that means that your final answer should be 31 over 45. Next question, 45 over 85. So we're looking for, again, one number in the same row or the same column. I can see that there is a number 45 over here and a number 85 over there. But also there is a number 45 over here, but there's no number 85 in the multiples of 15. So therefore the common factor that we want is the number 5. So 45 divided by 5 is 9. 85 divided by 5 is 17. So your answer should be 9 over 17. And the last one is 17 over 20. This is kind of a trick question because if you look at your multiplication table, you'll know that 17 over 20 is not in the same row or the same column. So this is down to its simplest form. So 17 over 20, we don't need to simplify. So these are the answers you should have got, and you should have left this one alone.